Okay, never mind, just pass over our editor. Okay. Now, homework. Okay, you should have your worksheet at the top. Okay, let's do a bit of arrangement first. Worksheet should be at the top, followed by 3 graph papers, question 1, 2, and 3. Okay, and then 1 full scat paper that has your question 4 and 5. Could you just help me remember, okay, I forgot what was the instruction that I gave. For exercise 6B, is it? What was the homework that I gave you all? 6B or 6C? 6B or okay. Exercise 6B, did I say that you want the same full scat or the separate full scat? Same. Okay, let's say that that's great. Okay. If you need it on a separate full scat, never mind. Okay. Just make sure that it is in a continuous manner. Worksheet on top, followed by 3 graph papers, followed by full scat paper. Okay, can you staple all of them together? Make sure you write your name and label your question numbers as well. Okay? Okay. Done already? So staple all of them up first. Okay, I haven't gone through and asked. I know some of you came to me telling me that you don't know how to do question 2 part D. Okay, before going into that, can I assume that question 1 is not a problem? Question 1, the graph question is not a problem? No. Okay. For question 2, am I right that there's problems in doing part D? Yes. Okay, so I'll just go through question 2 part D. I'm not going to draw the graph, okay, but you should be able to get your graph such that x and y axis, your graph is most likely to look something like that, going downwards, and it passes through a number 4. Okay, your graph should all look like this. This is for question 2. Okay, now in part D, the question says the line y equals to 3 cuts the graph at point P. Draw the graph of y equals to 3. So this diagonal line that we have is the graph of y equals to 4 minus 2x. Y equals to 3 is a what kind of line? Straight but horizontal. Everything is a straight line. Okay, so you need to be specific. We're looking at a horizontal line. Okay, so this is y equals to 3, horizontal line that passes through the number 3 over here. Okay, so you should be having that. Yes, yes, if you got it wrong, then do a correction, use a green pen or something. Okay, hopefully it can be seen, otherwise use a different color pen. Yeah. Okay, then the question, so this is for part I. Okay, D part I, y equals to 3. For D part 2, it says, hence state the coordinates of P. P is supposed to be the point that passes through the lines. Okay. Hey, come on. It's not a canteen. I'm talking to you over there, the boy hiding behind the wall. That boy over there, stop what you're doing. I'm talking to you. Look at me. I'm telling you that you're making too much of a noise. Whatever. I don't care. You're making too much noise. Get your noise outside, elsewhere. Go. Okay. So, okay. So this graph y equals to 3. Okay. It's a straight line that passes through your diagonal line. So this point is actually the point P. To find out what is the coordinates, okay, we will base on the fact that from this point going to the y-axis, you see that the y coordinate will have to be 3, and then the x coordinate going downwards, reading from the x-axis, we get a number over here. So go and read your own graph and tell us what is the number that we get. Okay, so make sure you present your answer in brackets. Alright, so there should be a number So that will be your answer for D part. Okay? Questions? Then I would say that question 3, you might actually struggle in terms of part C, am I right? Question 3, part C. Okay, so let's look at question 3, part C. Okay, so in question 3, part C, you have your x-axis and your y-axis. Okay, not sure whether it looks exactly the same as what you would have. X-axis actually represents the number of months, and then your y-axis represents the weight. Based on the values given in the table, you will likely be having a graph that looks something like that, going downwards. Okay? Then in part C, the question asks to find the gradient of the graph. So to find out what is the gradient, look at 2 points. Okay, form your right angle triangle, do your rise over run. Right? So whatever working that you have, I think your answer is -2. Am I right? Do we get -2 for your gradient? Okay. So I don't know what are the values that you get, but upon simplification it should be -2. Okay. So your rise over run. And then because it is downward sloping, it should be negative. So answer that we get should be -2. Okay? Then in that same question it asks, explain what the gradient represents. Okay? Looking at the rise itself, the rise is actually all the values for the weight. Okay? And then the run is all the values based on number of months. The context of this question is that Janice went for a slimming program. So the weight is actually dropping, going down as the number of months passes by. Okay? Which makes sense because this person trying to lose weight, right? You don't go for a slimming program and then you gain weight. Then probably you should get your money back. Okay? So to interpret the graph, or rather interpret the gradient, we say that the gradient represents the weight that, let me paste it for me. The gradient represents the amount of weight that Janice lost per month, which is 2 kg per month. Okay, so because you're losing weight, that's why it is negative. So we don't need to say that it's a loss of -2. Doesn't make sense. Okay, the loss itself is already represented by the negative. We're just looking at the digit over here, which is 2 kg per month. Yes, Rishi? It depends how you place it, but I will go and check on it when I'm out, okay? But maybe you can copy this down first, okay? Any questions? Right? I will not go through question 4 and 5. Those are questions that I have already gone through something similar in class. I will expect that you know how to do. Okay? Likewise, for your exercise 6B, question 4 and 5, I will expect you to know how to do as well. Because we have done something similar in class already. Okay? So if no other problems for the graph questions, could you submit your homework to the front? Okay, make sure it's stapled properly already. Don't have a staple, then please borrow one from a friend. Okay? Why? Which one? You don't understand because you never really pay attention in class, right? If I try it, I want to see if I really do this. Okay? And after C, it would be nice to answer the question. And the first one is this. No name on the worksheet. Neither is there any name on the graph paper. Oh, same rule. Same rule can write a name on the worksheet.
1
If you had done your SLS and watched the videos accordingly, okay, I have gone through practice now 7, okay, in your SLS itself. If you have not been watching the videos and just randomly skipping it, I would recommend that you go and watch it on your own. I'm not going to repeat it. Okay? So practice now 7 is a prerequisite. That means it's a necessary condition for us to do this question. Okay? So looking at this question, it says that the height of the father is 50% more than that of the son. Okay? By how many percent is the height of the son less than the father? So there are two people over here, the father and the son. Father being taller, son being shorter. Okay? The question here now, okay, that we need to first think about is, would the answer be 50%? If the father is 50% taller, does it mean that the son is 50% shorter? Okay, the answer is no, right? We can think about it in a diagram manner. If we think of this diagram over here to represent the height of the son, how will it look like for the height of the father? Father is 50% more than the son. So in this unit over here, let me divide into two parts, into two 50%. That means for the father itself, which originally would be like that, 50% more, so that means one block more. Okay? So this will be how the height of the father would, okay, look like in a model form. Okay? Obviously the father don't look like this, son don't look like that. Unless the father and son are Lego blocks. Okay? But clearly they're not. Alright? So the question here now is the son actually 50% shorter than the father? It's clearly not, right? Because this size over here is not 50% the amount of the father. Right? Okay, so we need to find out what is the percentage. We will use some algebra. Although visually, just by looking at this, we may be able to know the answer already. In fact, we know that it is 1/3. Okay, 1/3 of the entire of the father, right? And we can convert 1/3 into a percentage. Okay? But then, okay, may not always be so clear-cut 50%, sometimes can be 20%, may not be that easy for us to draw a diagram. So let's learn an algebraic approach. We let the height of the son be x. Okay? So this entire size over here is x. Then the height of the father okay, what would it actually be? If these two blocks over here is x, okay, the father is actually half more, okay, so that would be 1.5. Because this size is 0.5x plus another 0.5 plus another 0.5. So in total it is 1.5x. Agree? So the height of the father is 1.5x. Okay? Then we're looking at the difference in the height in order for us to find out what is the percentage. So the difference in height will be 1.5x minus x. That is 0.5x. Okay? So the required percentage which is how much shorter is the son from the father, right? Okay, so that will be the difference, which is 0.5x, with the father being the base, okay, and that will be 1.5x, because the comparison, we are comparing from the father itself, so that's why it's over 1.5x, and convert this to be 100%, because you're looking for a percentage, okay. We can simplify this fraction, x and x can cancel out, right? Because I can divide the numerator and denominator by the same factor x. And then everything is just numbers already. 0.5 over 1.5 times 100. Remember, we don't times the percentage sign. Okay? So this explains why our answer would then be 33 and 1/3%. Okay? So that will be the answer. for that before we go into the next objective. Okay, so the next and also the last objective for chapter 8.1, 8.1 only, okay, is to compare two quantities by percentage. Alright? Now, if I say this class, okay, or maybe I say, okay, let's use this class as a context. Okay, we have a mix of 105 and 106 students, right? Okay, so let's say 106 has a higher percentage of passes than 105. Okay? How many students from 106 we have in this class? Share.
I'm offended.
How many? I don't remember also. Wait, what? 160, 1, 2, 3, 4, 5, 8, 3, 4, 5. Yeah, 1, 2, 3. Lucas is right. Then after that, 3, 4, 5, 6, 7, 8, 9. We got 9, right? Okay. So we got 9, okay, 9 students in our 106. Total in our class got 33 students. 33 minus 9 is how many? 24. Is it? 24. Okay. So, if I say this statement, 106 has a higher percentage of passes than 105, does it mean that we have more people passing in 106 than 105? Okay, so my question is, does it mean that there are more people passing in 106 than 105? Okay, so that's my question. How many of you will say yes? Who says no? Okay, so I see that the 106 students not really raising hand. I'm not sure whether I'm trying to defend your something over here. Okay, but the answer would be depends, right? May not actually be, right? I mean we are not able to fully say determine the number itself because I did not give you any percentages here. Okay, but we definitely cannot conclude that just because there's a higher percentage, it means that there's more people. Right.
There's 10 students on 106.
There's 10 students on 106. Oh, okay. 10 students. Then come here 23. Okay. Thank you. Alright, so it doesn't mean that with a higher percentage, it means that there are more people. Because why? If let's say, okay, 106 has 50% passes. Okay, how many people does that mean? 50% of that is 5, right? Okay, I didn't prepare this beforehand, so let me do a little bit of math first. Let me count back first. Okay, so let's say so let's say 105 has 39% passes. Estimate okay? 39% passes. How many, okay, maybe let's give a nice number, 40% passes. How many would that be out of 33? 40 over 100, right? How to count with 40 over 100 times 23, right? How many people are there? Is that 46 over 5? Okay, so that was about 9 people. Okay, of course no such thing as 9.2 people lah. Okay, unless some of you come to class with half a brain or something like that. Okay, which I think maybe sometimes true. Some of you come to class with half a brain sometimes. Okay, so in this case, okay, clearly we see 106 has higher percentage passes, 50 being more than 40. Okay, but then look at the number of people wise. Alright, 105 actually has more people passing. So we cannot always rely on percentage itself, okay, to understand the situation. Sometimes we need to really know what is the base number. So the base number in this case is different. Unless we have a case of half this class, okay, is 106, the other half is 105. That means if let's say we have 15, 15, okay, then yes, we can rely on the percentage to say something. Okay? But in this case, because the base number is different, we cannot actually say that there are more people passing in 106. By percentage wise, yes. But by quantity wise, the answer is no. Okay? So I want us to be very clear and be careful about the base quantity that is being used when calculating percentages. Why we need to be sensitive to this is because we don't want to be deceived, okay, when you grow older by information that you read online, on your news, okay, or newspaper. Sometimes they exaggerate things, okay, by saying, wow, 80% of people pass the kind, and then you think like, oh, okay, that's a very big number. Actually, 80% pass is actually just that 1%, okay, or 2% in that cohort, right? Sometimes, let's say you receive your O-level results, you see your seniors receiving O and N-level results, okay, like, wow, 100% pass actually that cohort only 1%. Yeah, sometimes it happens that way, right? Okay, if you really look at the information, okay, there are subjects whereby there's only 1%. For example, Tamil. Okay, sometimes our school does have a lot of Tamil students. Okay, they will announce 100% pass, actually just 1%. Okay, alright. Although it is still worth celebrating. Okay, it's still worth celebrating, but we sometimes celebrate too much because it's actually just 1%. Alright. So let's take a look at practice now 8. Okay, textbook page 11. Right? Practice now 8 is actually a question that we have done on SLS. Okay, I just want to run through our answer for the sake of presentation. We do the same to find the percentage of people in village B that attended. Yes. Yeah, help us out. times 100%. And keying that into our calculator, we get 14%. Okay, so by proportion, although village B has lesser people going, okay, attention over here please, okay, right, although there's lesser people attending for village B, but looking at proportion, there is a higher proportion of people from village B that is attending the party. So therefore village B had a higher proportion of people who attended the party. Okay, guys, you appreciate that you don't have the conversation near the window. It does distract people. Okay, so that is for practice now 8. Any questions? Yeah. Are we ready for practice now 9? Okay, so in practice now 9, right, we're looking at different kind of berries and also the amount of sugar in each of the type of berries. Okay, then the question is asking or saying that Cheryl's doctor advises her to reduce her sugar intake. Okay, so she needs to reduce the sugar amount. So advise Cheryl which of the 4 berries has the lowest sugar content. Okay, we need to look at proportion. How much sugar is there in the amount of fruit for that mass itself? Sometimes the fruit can be very big, but the sugar can also be a lot. Okay, or the fruit can be very big, but the sugar can be very little. So we need to look at the proportion of sugar to the fruit itself to decide what is the best fruit to recommend to Cheryl. Okay, so we need to calculate this individually. Okay, so we calculate for the blackberry first. So first, percentage of sugar in blackberry. That will be to take 0.439 over 9 times 100%. Okay, and that would give us 4.79 over 90%. Okay, sorry? Because you're looking for sugar in the fruit. In blackberry, there's 0.439 sugar, right? Then the fruit is 9 grams, right? We're looking at blackberry. Yeah. Okay. Then we press calculator. A reminder that we should always give our answer to exact when possible. So I strongly suggest that you press your calculator, check whether you can get this number or not. Okay. Don't always rely on me to give you the correct answer. Okay, then we do the same for the percentage of sugar in blueberry, raspberry, and strawberry. Okay. Okay, so the working is actually all about the same. Okay, these will be the amounts that are found in the respective berries. Okay, so because she needs to cut down on the sugar intake, which berry should she actually eat? Okay, so we find that sometimes all these are mixed numbers, difficult to tell, right? So you may want to know what is it in decimal as well. So this will be about 4.87. Okay, and this is about 4.42. This is about 4.66%. Okay, so by comparing decimal will be easier. We can clearly tell that the sugar in raspberry is the least, and therefore Cheryl should eat raspberry instead. Yeah. Do we still call a strawberry a berry? Strawberries are not berries, really. I didn't know that. They are not. Then what is considered a berry?
A banana.
Banana is a berry.
Banana's a berry.
Really?
Yeah.
Why?
What the heck?
So berries, as long as seeds are inside, there is a berry.
Inside, yeah.
So a grape is a berry.
Yes.
Oh, I never knew that. Is it true? You learn this in science, ah?
No, we didn't know.
They learn this on what? TikTok? Okay. I really don't know. Okay. Oh, now I know. I will have things to share with my math department colleagues then. Okay. I'm sure nobody in the department probably knows. Okay, sure. Alright, so that's it for our chapter 8.1. Okay, homework. There's quite a lot, huh? Okay, so get ready. Okay, this is in your textbook, page 13 to 14. Sorry, I somehow lost my textbook there. Just page 13 to 14.
Because the seed inside the seed. The seed inside the
Okay, question 3, 5B, D, 9A, B, 12A, C, D, H, 13, 14, 17, 21. Okay, because this entire section very large, huh? Okay, so therefore, we have 4 objectives to cover, and hence we will have this amount of questions. Because percentage is very widely used in life. Okay, so this one due when? Due on? When do I next see you? Tomorrow?
No!
No lah. Okay, due next Monday. Then
Next Monday.
Okay, so the first thing that we will be looking at is percentage change. Okay, so in percentage change, we want to be, there is a formula to actually go about doing our calculation, right? But before we go into a formula, okay, I want to ask a simple question. If this comes salary increase by 5% from this one is May, right? From April. Okay. And her salary decrease by 5% from May. Okay. How? Okay. Is there any change in our salary?
Yes. Yes. We went up.
Okay. So let's say April itself to May, we're looking at an increase of 5%. Okay, from the amount that I earned in April. And then from May to June, okay, based on this statement, there's a decrease of 5%. Okay? So at the end of the day, so decrease of 5% from what I earned in May. Okay? So the amount that I'm going to earn in June, is it the same as the amount that I earned in April?
No.
How many of you will say yes? It's the same. Who says no? Okay, who is not sure? Alright, it's okay to be not sure. Okay, the short answer to this is no, it's not the same. Okay, it's not the same. Alright, you cannot see it as though because down here increase 5% and down here decrease 5% and then conclude that they can cancel each other out and then end up my salary is the same. No. Because what I mentioned earlier on is that this increment of 5% is from what? It is from my amount in April. So in April I earn a certain amount. And then, okay, for what I earn in June, it is going to be a decrease of 5% from what? From May itself. Right? My May amount and my April amount, they are different. So the base is actually different. Okay? So just now we have already covered that so long as the base number, the 100% amount is different, okay, then we cannot compare side by side just by looking at the percentages. So we need to be very careful about this. Okay? So the short answer to this is no, but we are not yet going into calculating okay, what is that exact percentage change inside. Right? So percentage change formula is fairly simple, I feel. Okay, so in order for us to find out what is the percentage change, okay, we need to know what is the change amount over the original and then times 100%. Since you're looking for percentage change. Okay, so example. Okay, today I earn $200 maybe. Okay, today. Then tomorrow I earn $300. Okay, this is today, this is tomorrow. What is the percentage change in my salary or my wages? Okay. So clearly you can see that there's an increment because $200 to $300. So that is what we call our percentage increase. Okay. So the change itself, the change amount, is the difference in the amount. So we always take the big number minus the small number over the original the one that's earlier, that will be 200. And then we multiply by 100%. So that is how the formula is being used. Okay? So in the end, upon calculation, that will be 50%. So I am having a 50% increase in my wages. So what's the question? 90. Okay. So let's say, what if instead the other way round? Okay, that today I earn $300. Today I earn $300. And tomorrow I earn, okay, $300 today and $200 tomorrow. Okay, what will the percentage change be then? Okay, very obviously from the amount we see that it is a decrease, so we can call it a percentage increase. The difference remains the same, which is 300 minus 200. But the base changes now because the original amount refers to the one that I'm earning today, which is $300. And then I times 100%. Okay, so in this case, 300 minus 200, that's 100. 100 over 300, that's 1/3 of this. So that's 33 and 1/3%. Okay. So we need to be very careful that percentage increase may not be exactly the same as the other way round. Okay? Because the base amount is actually different. So this may help us to illustrate the idea about how just now my April to May to June. Okay, if down here is increased 5%, down here decreased 5%, it may not mean that I am back to the starting point. Because we can clearly see that